Hi. So today we are going to learn linear programming, which is part of our operations research syllabus. So uh, I won't delve into the theory much. It's very easy, um, but there might be a few things which can become very confusing, such as decision variables, show hai, then minimizing, maximizing, why, what. So all of this can be explained, but if you need that, I will explain it for sure. For now, I'm just going to show the sums and all of that. But a quick yeah, operations research dedicates itself towards efficiency. This word efficiency is everything in operations research: efficiency in production, efficiency in transporting, efficiency in sales, efficiency in advertising, efficiency, and all these efficiencies. What does efficiency mean? Why? Let's say um, efficiency means maximum profits at minimum cost. So whatever answer we get, right, I'll show the sums and I'll explain. So these answers are basically the values at which I will be gaining the maximum profit, or I'll be spending the minimum amount. That is, my cost will be minimized. So a linear programming problem formulation. This is the first step of any linear programming problem. You formulate the question. You formulate equations through the question. Now, question can be in table format. Question can be in paragraph format. And let's take the this table format first. So you read the question: two types of products, P1 and P2. Okay, the profits are given again. Okay, these two types, three types of machines. So these require. So they've said that they have to go through these three machines, and machines are per day, and time required on each machine to produce whatever 1 kg. Okay, so basically machine 1 pay for producing P1 I'll need 3 kgs, for P2 I'll need I'll need 3 hours to produce 1 kg, I'll need 2 hours to produce 1 kg of P2. Simple. Now whenever you get a table, right, think about it. Can you control the profit per kg? Can you? No, right? Because profit is something which is given, and profit is cannot be changed. Machines, can you increase the number of machines? No. Well, in real life you can both control the profit as well as control the machines, but in this question particularly you can't control any of those, neither the profit nor the machine. Well, what about total available hours per day? No, obviously not, because you cannot. If the total available hours a day are 600 for machine 1, you can't go beyond that, otherwise the machine might malfunction or it might stop working. So let's through the process of elimination, we can't take this, we can't take this, uh, I mean these three machines, and we can't take these total available hours. So now we have this middle part. What is this middle part? Well, as I said, 3 hours to produce 1 kg, 2 hours to produce 1 kg, 3 hours to produce 1 kg, 5 hours to produce 1 kg. Produce in the sense process that whatever P1 product is. So now if you think about it, right, 3 hours for 1 kg. What do we need to decide? We need to decide what will be our maximum profit. Why maximum profit? Well, because this question talks about profit. And profit, as a firm, you'll always think about maximizing profits and minimizing costs. You'll never think about maximizing costs and minimizing profits. So whenever profit is given, you maximize it. Sometimes revenue might also be given, so revenue ko bhi maximize karo, and cost will be minimized. So we have been given profit, so we are maximizing it. Now let's go a step further. Now we know that when I spend 3 hours to produce 1 kg, I get 3 hours, 1 kg is produced of P1, in the sense that it gets processed, 1 kg gets processed. Then 3 hours of machine 2, and then 5 hours of machine 3, and then I get a final product. This final product, when I sell, because it's 1 unit, I get 30 rupees. So now if you think about it, again, I'm using the phrase think about it a lot, but then if you look back, you want to maximize profits, and profits are rupees 30 per unit and rupees 40 per unit. So now you come to the important part, that is decision variables. Decision variables are something which is like the key of the problem. Once you understand what the decision variables should be, it will be smooth sailing forward. Let me just check once if I'm recording or not. Yeah, I'm recording. Okay. So what is decision variable? Well, decision variable, as the name suggests, let's dissect it into two parts: decision and variable. Decision is something that is in our hands as the manager or as the person appointed for this question or this case for that matter. Decision is something that is in our hand. Decision about what? Decision about a certain variable. Variable, as the word suggests, something which varies. Now, decision variable is something which is a variable, something which is changing in the sum, which will affect our decision and which will let us get our objective, will push us towards our objective. What does this mean? Well, in this case, x1 is the amount of p1 and x2 is the amount of p2. That is the decision variable. x1 is one decision variable, x2 is another decision variable. Because we know that rupees 30 is profit per unit and rupees 40 is profit per unit of p2, I forgot to say p1 before, rupees 30 per unit profit of p1 and rupees 40 per unit profit of p2, if we replace per unit by the total optimum production, the word optimum, if you remove it out of this problem, again, it doesn't matter. If you can keep it, if you want to keep it, you can keep it. Total of x1, total production of x1 or total processing of x1 multiplied by rupees 30 plus total production of x2, total processing of x2 multiplied by 40. What will this give me? If rupees 30 per unit is profit for P1 and rupees 40 per unit is profit for P2, rupees 30 multiplied by total P1 produced. That is 30 is profit per unit multiplied by total P1 produced. That will give me total profit of P1. That is total profit that I'll get from producing and selling P1. On the other hand, total profit from P2 will be 40 multiplied by total production of P2. Now, again, as I was speaking, I fumbled because saying this again and again, total production of P1, total production of P2 is a bit lengthy and it's a bit slow and it's a bit inefficient. And operations research is all about efficiency. So we attach a variable to it. Now this can be x1, y, x1, x2, x, y, a, b, whatever you want. So so that's your decision variable. Basically, now if you'll think again, look back at the thing that we were discussing. We wanted to maximize profits, minimize costs, maximize profits. As I said, rupees 30 into x1, why x1? Amount of P1, total production of P1, plus rupees 40 multiplied by total amount of P2, total production of P2. What will this give me? This will give me the total profit. Let's say I'm producing 1 unit, then I'm getting rupees 30 plus rupees 40, that is rupees 70. But I'm producing 2 units, rupees 30 into 2, 60 plus rupees 40 into 2, 80, that is 140. So this, the variable, when I substitute the variable with an actual amount, I am getting the profit. But I don't know what the actual amount is. I want to know what the actual amount should be in order to get the maximum profit with my available constraints. Introducing a new term called constraints. So that is why we write this. In order to maximize profits, we establish the objective function as, instead of writing this sentence, you can simply write, let me open our docs. You can simply write maximizing profits Z equal to then 30x plus 40y. 40y or 30x plus 1 plus 40x2. this means the same. So we are attaching instead of, again, because we knew here that the problem that was occurring was that it was being a mouthful to say total production again and again. Similarly, it can be a mouthful saying again and again maximize profits by using the equation 30x plus 40y. Yeah, 30x1 plus 40x2. We simply attach a letter to it. For this case, it's z. Usually you prefer to use z. You can use something else as well, but z is the usual term. So now I simply say maximize z. Yeah, that's it. I write maximizing profit z equal to 30, and then I write maximizing z. That's it, and that will work. So you attach a variable to it. Now let's get back to this. Constraints. Now this is where the important part kicks in. Since 1 kg of P1 requires 3 hours, see, all this is typed, you can all this is written, you can simply go ahead with it. Now, okay, machine 1 के साथ जाते हैं अभी. Back to machine 1. Okay, now machine 1 produces both P1 and P2. And according to the sum and according to the table, I will go with the assumption that it can do both of it simultaneously. Can I do? Let me think. No, it can't. Sorry, my bad. This is a different case. Sorry. So, because there's nothing specified, I will not go with the assumption that it does it simultaneously. Otherwise, the calculation will be a mess. So, I go with the assumption that if P1 is being produced, P2 cannot be produced, and P2 is produced, P1 cannot be produced. So, machine 1 is this column, right? Machine 1 mein total number of hours is 600. 3 hours per unit of X, 2 hours per unit of Y, that is P2. Correct, as we've mentioned here. So 3 into multiplied by total production of X plus 2 multiplied by total production of Y should be 600. It cannot go beyond 600 because total available machine hours is 600. It cannot go beyond that. So it's 3x plus 2y equal to 600. But there's a big but. That's what she said. So basically, I'm sorry. So basically, 3x plus 2y equal to 600 is not feasible for one single reason, that 600 is the maximum hours available. It doesn't mean that I have to use all 600 hours. I might be able to use less of machine 1 and use more of machine 2 in order to maximize profit. That might be the case. I don't know. I'm still solving the sum. So what do? Well, I use this sign less than equal to. So what is this constraint? I only have 600 hours per day. I can only use 3 hours per unit of X and 2 hours per unit of Y. So if I add the hours used by X and Y, that is 3 multiplied by amount of P1, that is X assumed here, 3x1 plus 2, that is amount of P2 x2. So 3x1 plus 2x2 less than equal to 600. Is that understood? I have 600 hours, but I can use less as well. And the 600 hours have to be divided in 3 multiplied by x1 and 2 multiplied by x2. So that's the first constraint that we have, 3x1 plus 2x2 less than equal to 600. I hope you understand why less than sign is there, less than equal to sign, because I have a limited number of hours. Similarly, I have machine 2, 3x plus 5y equal to less than equal to 800. 5x plus 6y is less than equal to 1100. Same logic. I only have 1100 hours, but I can use less as well. Now, there is this very famous non-negativity constraint, which usually you might forget, but try not to. x1 and x2 greater than equal to 0. I've forgotten this n number of times in 11th, and it really, usually in the start you might forget, and you will probably lose either a mark or half mark for it, and then you will get the hang of it. That's what happened with me. So yeah, x1 greater than equal to 0 and x2 greater than equal to 0. I think this is pretty easy to understand. Amount of P1 is greater than equal to 0 because I cannot produce negative goods, right? I can produce 0. I don't want to produce P1. I will only produce P2. But I cannot produce negative of P1, right? I can't possibly do that. That's why we have to give this negativity constraint. This is like, I don't know why humans have decided that we should specify the non-negativity constraint. I have no idea. But for a machine, it's quite understandable why non-negativity constraint is important. When you're using some software, it's important to have this non-negativity constraint. So formulation with different types of constraints. Now we studied about the less than equal to type, which was I had a limited number of hours and I had to fit my production within those hours. How to solve this, I'll explain after this example that I take. This will be a bit quicker. The table is not here, so you might want to prepare a table. I'll tell you a quick way of preparing a table. If I can use Jamboard, I guess. Jamboard. Usually these videos go a lot. Oh, why do I have this? Okay, ignore this. Yeah. So let's get back to this. Okay, a company owns 2 flour mills. What should I do? I'll take this down. I'll put it here, and I'll take this here. Yeah. Does this work a bit to the left? Yeah, this is better. So a company owns 2 flour mills. What I usually do, this is something which I do. You may or may not like to do this. I simply skip to the last line. How many days per month should each mill be operated in order to meet the contract order most economically? So we have been given that we need to decide how many number of days per month. So we already have our x1 and x2. Got it? Because x1, let me take this sentence is a bit misleading. It's x1 and x2 are the number of hours that mills A and B will run. Let me take this pen. How many mills do we have? I'll present something very rough. Okay, so a company owns 2 flour mills, A and B, okay, which have different capacities for high, medium and low quantity. The company has entered a contract to supply flour to a firm every month with at least 8, 24, 12 and 24 quantities of high, medium and low quality respectively. It costs the company rupees 2,000, rupees 1,500 per day, okay. On a day, mill A produces 6 to 1, okay, mill E, okay. So yeah, I'm saying okay a lot, but I'll write this high. Can you write no? Medium and low. So high, medium and low, and we also have A and B. Ignore the columns if possible, they are a bit messy, but yeah. So let's go back. High, medium, how many days per month should each mill be operated? So we've been given the cost. If you'll read, it costs the company. So cost, as the word comes, we know that this question is definitely for minimization because cost is minimized. It costs the company rupees 2,000 and 1,000 per day to run mill A and B. I'll keep this aside for now, but yeah. Now constraints. What constraints do we have? On a day, mill A produces 6, 2 and 4 quintals of high, medium and low. So I have this K. On a day, it produces 6, 2, a mouse is not helping my handwriting, 4, and mill B produces 2, 4 and 12. Now, how many days? Okay. The company has entered a contract to supply flour to a firm every month with at least 8, 12 and 24. So we have at least, the word at least, and here we, okay, this didn't have a written here, but at least means minimum, right? At least means at the least minimum. So we go here, we can write it here 6 2. So we need minimum 8. Let me write here okay, I won't be able to write minimum, but I might be able to write min. Yeah, wow, it looks like, yeah, minimum. So minimum 8, minimum 12 and 24, correct. So it has to meet these demands. पहले कैसे था? It only had इतना, it only had 600. Now it at least must have 800. It must at least have 800 मतलब you can produce more than 8 as well, you can produce more than 12, you can produce more than 24, but at least you must have 8. So you make this table. अभी पेन से बनाया इसलिए थोड़ा slow है, but usually it will be a bit more fast, it will be a bit faster when you do it on paper. What I did was I went here, how many days per month should each mill be operated. So we have, this will be x1, and we have 6 per day on a day, 6 per day, 2 per day and 4 per day, high, medium, low. So now we think about it. They want to know how many days per month, right? So we just simply write, let x be the number of days mill A runs, let y be the number of days mill B runs, mill B. Yeah, so x be the number of day, y be the number of day. So when I take these these are my decision variables, because they want to know how many days, they want our decision how many days. So now first we go in our cost. What do we want to minimize? Our cost. So we have 2000 per day and 1500 per day for A and B respectively. So we quickly write 2000. Okay, I'll say orally. So you have 2000 per day for mill A and 1500 for mill B. So now we look here. So 2000 into x1, as we decided x, I'll say x be the number of days mill A runs and b be the y be the number of days mill B runs. So now we go with the constraints. I hope this was understood. Minimize, see they've written minimize. You can write z in order to kind of simplify your A, but it's up to you. Okay, so then we go here again with the table you might have drawn. So 6, high they need minimum 8, you can use A as well, you can use B as well. So number of days mill A runs is 6, is x. So 6x will give me the number of quintals that A produces of high quality flour, and 2y will give me the number of quintals B produces of high quality flour. So because 6 is the number of quintals that it produces a day, so 6 multiplied by x plus add 2 multiplied by 2 multiplied by y will give me equal to 8, should at least be equal to 8, but it can be higher as well, it can be either 8 or more. So 6x plus 2y greater than equal to 8, 2x plus 4x ये तो इधर ही है, you take this, 2x plus 4y greater than equal to 12, 4x plus 12y greater than equal to 24. You may reduce these, divide by 2 each go, but you prefer not to do that. And don't write, if you want to reduce it, don't reduce it here, reduce it while you're solving, don't reduce it here. The reason you don't reduce it here is because sometimes it's this, like without reduction is a bit more clear, it is a bit more clear to read. I'll simply go like x1 is the number of days mill A runs, right, and 6 is 6, so 6 should be the number of quintals A produces. That's how it's read sometimes. So try not to reduce it here, reduce it while solving, it's okay. So yeah, pretty straightforward. Now there's this trick that is there, and trick nahi bolenge, but a general rule of sorts. In maximization questions, the sign should always, for the constraints, should always be less than equal to. Not for non-negativity constraints, only for the linear constraints. The sign should be always less than or equal to. Similarly, in maximization, the signs should always be less than equal to, and in minimization, the signs should always be greater than equal to. This is kind of a thumb rule. The reason for this, I mean, as we are all understood, प्रॉफिट्स हमेशा हमको ग्रेटर देन इक्वल टू ही चाहिए. It can be as great as possible, right? Greater than equal to represents what? In an infinite. Anything greater than 8 and above. It can be 1.3 million, 1.5 million, whatever number you can imagine, greater than equal to. But जब हम production कर रहे हैं, in order to increase profit, I will produce more. But production में there's always going to be some limit. Whereas cost में you can spend any number of any amount you want. You can spend as much as you have. So it's greater than equal to. Usually this is how the logic goes. I mean, in this question, if you think about it, they want at least 8. Matlab, they could have said they want at most 8, but then we would have needed to flip the sign. This is a thumb rule, remember this. So flipping the sign, you multiply by minus. But I'll probably explain this to you in another way, not here though. Okay, that's it. I think it's 26 minutes 32 seconds, right? Okay, I'll explain how to solve these equations now. So this is basically formulating the equations. This doesn't give you the answer. What is the exact number of days A should run and B should run for efficiency, right? These are just questions. These are not answers. So then one of these methods to solve linear equations is graphical analysis. Graphical analysis is I personally don't like it because it can be a bit inaccurate at times in the way that if you're using the graph, like purely the graph to find out the values, then it can be a little bit difficult. If you're using the solving the equations to find the value, then it is okay, then it is allowed. Then it's precise. So this maximize 30x1 plus 40x2. If you remember, it is our question number 1, which was P1 and P2. So we take those conditions that we have, constraints as we say. These are the constraints, and this is the maximize ka equation. Ab graphical analysis, yeah, graphical plotting mein, we keep the maximize equation at the end. We'll use it at the end. अभी उसका कुछ भी use नहीं है, no use at all. What do? You use these constraints. Now, this is kind of a concept again. Should I use it? Okay, I'll use docs perhaps. Yeah. So this is a constraint, which is this is a rule of sorts, a thumb rule of sorts for any equation, linear equation, right? So if I'm writing 3x plus 2y, and if you know this, I'm extremely sorry for being so teaching all these minus things, but yeah, it's important to know this. So when I'm writing 3x plus 2y equal to 600, there will be a line. Now this line will be, let me horizontal line. Oh, that was a bad line. Where is that pen? Is this a pen or is this a highlighter? It's a highlighter. Yeah, it's a highlighter. Okay, anyway, so I know where the okay, it might not be here, sorry. Okay, I know. So basically, whenever you have this equation, right, x and y can have any values so long as it can it can solve, it can fulfill this equation of something. Fulfill is not the right word, but it can satisfy this equation 3x plus 2y. Let me use Jamboard, it's a better example. I'll be able to draw a line and help you there. So we basically had 3x plus 2y equal to 600. So this equation, now I'll draw a line. I don't know if this is the solution to this equation. This line represents this equation, but let's say this line is drawn using this equation, that is 3x plus 2y. इसका मतलब क्या है? जब when I take this plane, right? So now, okay, this turn mute. Okay, so I have these values here of y 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and so I have these values of x here and y here. So if you'll see, this corresponds to here and this corresponds to here. So any number of this y and this x will satisfy this equation because this line pe they coincide here, right? Similarly, if I'll draw a box, let me see if we can go here, and if I draw this here and here, right? So now this value of x here and y value here will satisfy. Similarly, and if you know, this being a line, there are infinite numbers in this small space. There are n number of things that can fulfill this line. Because a line has infinite points, there are infinite number of solutions which can solve this. We don't want infinite solutions. We only want any two of these solutions. Any two values of x and y. Why so? Well, I'll show it to you. Now, the quickest way of getting these values of x and y, x1 and x2, is simply substituting x2 for 0 and x1 for 0 separately. So first you substitute 0 here, so you'll get x1 equal to 200, and then you substitute 0 here, so you'll get x2 equal to 300. Did you get what I meant? If they've written here somewhere, yeah. So as I substituted 0 here and 300, so I got this equation. But if you remember what I was speaking about, I said equal to 600, but there's also less than equal to 600. That will come into play later. So I want just two solutions, one of x1 and one of y1, x and y, or x1 and y1 quickly. So what do? I substitute 0 here, y ke liye, and then I get 3x equal to 600, x equal to 200. Similarly, x ko 0 dal ke. So this is a quicker way of doing this. Usually you can get whatever, like n number of solutions, as I said, but this is the quickest way of doing that. So now I got those values. Which two values? 200, 0 and 0, 300. Again, I'll repeat why we took 0, right? If you'll think about it, the quickest way of finding a point on x is this, using this the bar that we have here. On this line, the x bar, the value of y is always 0. So we want y to be 0 so that I can easily plot a point here. Similarly, when x is 0, the value will lie here. Similarly here, if you'll see 0, 200, 0, 200 is somewhat here. Sorry, 200, 0 is here, and 0, 300 is here. And as we know, to draw a line, I just need 2 points. So I simply drag a line from here to here. A Jamboard is the best for this. Let me clear frame, go here. One, two, three, four. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So if you'll see, if this is 100 and this is 200 and 3 and 4 and 5 and 6, and similarly here we have 1, 2, 3, 4, 5, that wasn't a 5, 5 and 6. So we have 2 points. To draw a line, we just need 2 points. We have those 2 points by substituting 0. We had 200 comma 0, which is somewhat here, and 0 comma 300, which is somewhat here. So I simply take and draw a line now. That is my first equation, my first constraint. Similarly, I do this for the second and the third constraint. The values here will come in points. You try to plot them approximately. So for either, let's say 0, 5x2 को डाला तो 3x1 equal to 800, x1 equal to 3 2s are 6, carry 2 6 6. So 266 के around है. Wait, 800 divided by 3, right? 3. Am I doing this correctly? 3 2s are 6, correct. And then 2, yeah, 6 7. 266 के आसपास. So if I'll go here, 266 would somewhat be here, and then if I substitute 0 here, 5x equal to 800, that value would be 5 1s are 5 3 6 160. 160 would be somewhat here. So I just simply drag and draw the line again, and last line is what? 5x plus 6x2, that is 0x would be 10 220. 220 would somewhat be here, and 6 1 6 5 6 6 7 6 58 153 approximately. 153 would be somewhat here. So I simply drag and drop. But that is a messy graph, so I'll use this now. Now, last point for the day, very quickly. It's already a long video. This was line 1, this was line 2, and this was line 3. We had these 3 lines, okay. Now, the shading part which comes in, okay. What you do is basically substitute 0 in x1 and substitute 0 in x2. So 0 less than 600 is the equation correct. If we substitute x1 equal to 0 and x2 equal to 0, will the equation be satisfied? That is x1 comma x2 equal to 0, then 3x1 plus 2x2 would be 0. 0 is less than 600, which satisfies the equation. So this line that is here, because it satisfies the equation, the highlighted part will go down SA towards the origin. This is again a rule which you must remember. I'll use red for that so that it will go down SA. You know what? I'll explain this better with my notebook because it's a little easier. I'll stop this video here.